for the systems. Okay, so here a quick diagram. We will go into it much deeper. But quick diagram what I got from Schnell. So Schnell use it actually in their standard presentation. So if we see the energy content, so we have here the kilowatt hours per norm cubic meter. We have here the biogas, that's the red line here. We see here the percentage of CH4 content in the biogas. And here we have natural gas. Natural gas is almost at 90–100% here. So, and here we can see how much kilowatt we will get out of the percentage. That's easy to understand. Actually, 60% is approximately 6 kilowatt hour per norm cubic meter. Where we are at natural gas between 90–100% at 9 to 10 kilowatt hour norm cubic meter of gas. This higher content means on the other side the knocking resistance is different. The knocking resistance, so it's on the methane number. The knocking resistance here, the knocking resistance. If it's higher, it's more safe for knocking. If it's lower, we can easier get into the knocking situation of the engine. So we can see here the biogas, it depends on the content of the CH4 content. And for example, if we take the sample here of 50% CH4 content, we have a methane number of 150 approximately. That means it's very resistant for knocking. Natural gas is very low. It's between 70 and 90 methane number. Okay, so let's go back to next page. And on the other side, we have again here the heating value, the energy content, so the percentage per kilowatt hour per norm cubic meter. And if we compare it to here, the flame speed, it's laminar flame speed, centimeters per second. You can see lower CH4 means lower speed of the flame in the combustion chamber. We're burning the gas slower, or the gas gets burned slower in biogas to compare to natural gas. So, and that means if we have a higher CH4 content, our flame speed get quicker or faster to burn the entire biogas in the combustion chamber. Okay. Here again, please let me know if you have any question or where we have to go deep in the next video. I will go into biogas much deeper in future videos, but if you give me immediate feedback, so maybe I can put it in some other videos in between, so that will be easier for you to understand what we are talking about, and for the whole education program. Okay, so here we are now on the function of a usual pilot fuel CHP technology. So here, the usual system based actually on a standard, so the basic function based on a diesel engine principle. That means on a diesel engine we spray through the injectors diesel into the engine over the combustion ratio and the temperature, it starts to ignite. So on a dual system we add the biogas, so that we use the pilot fuel, so the diesel, like sparks to ignite the biogas, but we need it during the full operation time. So it means from the startup we need pilot fuel, we need it through the whole operation of gas mode, and for the cool down phase until engine stopped. So the pilot fuel will be needed all the time to ignite the gas. And as the next point, everybody know the diesel engine, car, trucks and so on, to compare to the petrol engines or petrol cars, and have a lower fuel consumption. That is equal to a higher mechanical efficiency. So the higher mechanical efficiency will be transferred on a CHP unit from mechanical energy goes to the alternator into electrical energy. What goes into, or what will feed it into the grid as electric energy. Okay, let's move on. So, okay, function of gas auto spark plug CHP. So the gas auto spark plug CHP based actually on the auto engine technology with a spark plug. So the spark plug usually in a petrol engine will be used to ignite the injected petrol. In the gas auto CHP for biogas or for gas, the spark plug is used to ignite the gas. And so we have, as before, what I showed, we have different gas sources like natural gas, LPG gas, biogas, wood gas, landfill gas, and so on. So the spark plug will ignite the biogas or different gas sources, what will be added to the system. Okay. So let's go to the dual fuel CHP. So we have pro and contrast. I put pro and contrast of both system technology into place. So let's go quick through it and let me know if you understand every point, or we have to go into that deeper the next time. Okay, the pros of a dual fuel CHP unit. Through the technology of the dual fuel system with high compression ratio of the CHP, we will get a higher electric efficiency out of that system. As well, a big benefit is we have better and a more smooth ignition for weak gas, special for weak gas, where the gas is fluctuating or the flame speed of the gas is slower, so the CH4 content is lower. So it's much easier for a dual fuel system to burn the gas properly and burn the whole gas. That means not wasting gas through the exhaust. Stable and easy start and synchronization with pilot fuel injection. That means we're starting the dual fuel system with the pilot fuel, so like diesel, LME, or vegetable oil. So, and after we had synchronized to the grid, so the generator or the alternator is connected to the grid, then actually the gas mode starts, and that's why it's much easier to have a stable fuel quality. In this case, it's pilot fuel. That's in your case usual diesel, and this gives a much easier option to start, synchronize to the grid for this kind of technology. A dual fuel system can operate in pilot fuel mode without gas. For example, we can operate in diesel mode to heat up or supply heat to the plant or to the digester. So we can heat up the digester fermentation system and get it up to temperature that it produces gas. So we don't need any other heating system. So we can use the CHP to heat up the digester to produce biogas. This dual fuel system, it's much easier to operate with a dual fuel system with a lower gas quality or gas quality changes. We can even go and operate the CHP with a CH4 content of 30%, 35, 40%. So the usual gas auto engine get problems below 45% CH4 content. For dual system, it's not a problem at all to operate on lower CH4 content. Yeah, and another big option what I think does a dual system have, it's more opportunities and more stable to operate in island modes with weak gas. So island mode means without natural grid, so it's like a microgrid or island grid that the CHP only supply heat to supply electricity to the existing small grid, and the biogas, if we're talking about weak gas, we're talking about biogas, wood gas, landfill gas, etc. Okay, let me go quick back, and we have to do a quick stop. Okay, so we have here the contrast of a dual system. Yeah, sure. The opposite impact of higher electric efficiency means we have lower thermal efficiency. So heat in the form of hot water or heat in the exhaust gas, what may be used for different kind of other heat resources systems. For sure, the other negative point is we have additional fuel source what we need during the full operation. And the last point, last but not least, there are not many CHP manufacturers available what produce dual systems. Okay, let's jump over to the gas auto technology. So here we are on the pros of a gas auto technology CHP. So here we have the opposite